If you drive an electric vehicle, you have probably allowed yourself a quiet moment of satisfaction over the last 2 weeks. Oil prices just crossed $100 a barrel for the first time in 4 years. The Strait of Hormuz is under military blockade, tanker traffic has essentially stopped, and governments across Asia and Europe are panic-releasing emergency oil reserves to buy themselves a few weeks of stability. Meanwhile, your electricity bill has not changed. You charged your car last night, the same as always. The uncomfortable truth, though, is that your satisfaction is based on a misunderstanding of how oil works inside the global economy. And it is a misunderstanding that is surprisingly easy to miss, because the story the EV industry tells is technically true, but fundamentally incomplete. So electric vehicles do reduce the amount of oil burned to move people from one place to another. That is real, and it matters. But road transport for passenger cars only accounts for a fraction of total global oil consumption. Aviation, shipping, petrochemicals, fertilizers, and the industrial processes that built the very car sitting in your driveway all run on oil, and none of them have a meaningful electric alternative available today. The oil shock rattling the global economy right now does not care how many electric vehicles are on the road. It is already inside the price of everything you buy. So before this crisis gets worse or better, it is worth understanding exactly what electric vehicles can and cannot shield you from, because the gap between those two things is much larger than the industry's marketing suggests. Let's start with the number that tends to end conversations before they begin. There are approximately 58 million electric vehicles on the road globally right now, and that genuinely is a historic achievement. It took decades of engineering, subsidy programs, and consumer behavior shifts to get there. The problem is that 58 million is not the number that matters for an oil shock. The number that matters is the one sitting next to it. There are roughly 1.5 billion cars, trucks, and vans operating on the roads of the world today. That means electric vehicles account for just under 4% of the total fleet. Every time an oil price spikes, every time a tanker gets turned away from a choke point, every time a geopolitical crisis rattles an energy market, the other 96% of the global vehicle fleet is fully exposed, because it still runs entirely on gasoline or diesel the same way it did 10 years ago. Now, you might reasonably argue that the trajectory is what matters, not the current snapshot. And the trajectory does look promising on paper. EV sales hit a record in 2024, with more than 1 in 5 new cars sold globally being electric. But here is where the math gets uncomfortable. The average car on the road today stays in service for 12 to 15 years. That means even in a scenario where every single new vehicle sold from today onwards were electric, everyone globally starting tomorrow, the last combustion engine would not disappear from the world's roads until somewhere in the mid-2040s. The fleet turns over slowly, and it cannot turn over any faster than the physical rate at which old cars are scrapped and new ones are built. And that is before accounting for the part of the story that almost never appears in Western coverage of the EV transition. The motorization rate in developing economies, the number of vehicles per 1,000 people, is currently sitting at around 92. By 2050, that number is projected to nearly double as populations across Africa, South Asia, and Southeast Asia grow wealthier and begin buying their first cars in meaningful numbers. The vehicles those hundreds of millions of people are going to purchase are, overwhelmingly, going to be combustion engines, because that is what the second-hand market offers, that is what local fuel infrastructure supports, and that is what a family on a modest income in Lagos or Dhaka or Manila can afford. Electric vehicles are transforming the roads of Oslo and Shanghai. For most of the world, that transformation has barely begun. Here is what the electric vehicle conversation almost always leaves out. When most people think about oil dependency, they picture a petrol station. They picture a combustion engine, a fuel tank, a tailpipe. And because electric vehicles eliminate all three of those things, the assumption becomes no tailpipe, no oil problem. But road transport for passenger cars only accounts for roughly half of everything the world uses oil for. The other half is a collection of industries that electric vehicles cannot touch, have never claimed to touch, and will not be able to meaningfully replace within any timeline that is relevant to the crisis unfolding right now. Take aviation. Commercial flight is one of the most energy-dense activities in the modern economy, and it runs entirely on kerosene derived from crude oil. And there is no commercial long-haul electric aircraft anywhere close to entering service. The most optimistic projections for sustainable aviation fuel the biofuel-based alternative that the industry is betting on, suggest it will cover roughly 2% of total aviation fuel demand by 2030. The remaining 98% is still conventional jet fuel. Every flight you take, every cargo shipment that arrives by air, every fresh food import that depends on air freight, all of it is exposed to whatever is happening to oil prices this week. Then there is shipping. Roughly 90% of everything traded internationally moves by sea, and the vast majority of those vessels run on heavy fuel oil. And the container ship that carried the components for your electric vehicle's battery from a port in China to a factory in Europe burned thousands of tons of oil to do it. Maritime electrification is in its earliest experimental stages, confined to short coastal routes and nowhere near the scale needed to matter. And then there are petrochemicals, the part of the oil economy that does not burn at all. In 2024, chemical feedstocks and aviation each accounted for around half of global oil demand growth, and the feedstock story is one that almost nobody who talks about the energy transition wants to discuss in detail. Oil is the raw material for plastics, synthetic rubber, fertilizers, detergents, pharmaceuticals, and the insulation coating every wire in every electronic device you own. None of those products become less dependent on oil because more people drive electric cars. The dashboard of your EV is made from oil-derived plastics. The tires it rolls on contain oil-derived synthetic rubber. The packaging around the battery cells was almost certainly petroleum-based. Electric vehicles are genuinely reducing the amount of oil burned to move people around, but they are operating on one floor of a building that has 3 floors, and the other 2 floors are not getting any less flammable. Which brings us to the thing that even the most passionate EV advocates rarely want to talk about. Let's talk about where electric vehicles actually come from. Building a single electric vehicle requires extracting lithium, cobalt, nickel, manganese, and graphite from mines scattered across Chile, the Democratic Republic of Congo, Indonesia, and Australia. Those mining operations run on diesel, large open-pit machinery, haul trucks, processing equipment, none of which runs on electricity generated from a clean grid. Each EV battery contains on average up to 10 kilograms of lithium alone, and lithium is just one of several minerals that need to be hauled out of the ground, crushed, refined, and chemically processed before it becomes the flat, dense rectangle sitting under your car's floor. Once those minerals are processed, they are loaded onto container ships and transported, on bunker fuel, to battery manufacturing plants, so predominantly in China. The finished battery cells are then loaded onto more ships or cargo planes and transported to vehicle assembly plants in Germany, the United States, South Korea, or wherever the final vehicle is being built. Every step of that supply chain between mining site and showroom floor is powered, in significant part, by oil. The vehicle itself is then assembled using industrial machinery that draws on an electrical grid. In most countries, that grid still generates a significant share of its power from natural gas or oil, and the vehicle that rolls off the line is not oil-free in its materials either. The bumpers, door panels, dashboard, seat foam, carpet, weather seals, and wiring insulation are all petroleum-derived plastics and synthetic materials. The tires, 4 of them, so replaced every few years, are roughly 20% synthetic rubber, which comes from oil. None of this means electric vehicles are not worth building. They genuinely are, and the life cycle emissions of an EV are substantially lower than an equivalent combustion engine vehicle, even accounting for all of the above. But the framing of EVs as a clean break from oil dependency is not accurate. They are, in many respects, a downstream product of the very system they are meant to replace. Built with oil, shipped with oil, assembled partly with oil, and rolling on tires made from oil. The transition is real. It is just not as clean as the brochure suggests. So let us bring all of this back to what is happening right now, because the timing of this video is not accidental. The International Energy Agency's March 2026 oil market report described the current situation plainly. The war in the Middle East is creating the largest supply disruption in the history of the global oil market, with nearly 20 million barrels per day of crude and product exports currently disrupted. The Strait of Hormuz, a channel barely wider than a small city, is the single choke point through which Saudi Arabia, Iraq, Kuwait, and the UAE export most of their oil. When that channel closes, those barrels do not find an alternative route quickly. The pipelines that bypass the strait carry a fraction of the volume, and the Red Sea route they feed into carries its own security risks. So you now consider what that disruption transmits into the broader economy. and notice how little of it runs through the fuel tank of a passenger car. When oil prices spike above $100 a barrel, airlines face an immediate and severe cost shock, and airlines have almost no ability to absorb that cost without passing it on. Ticket prices rise within weeks. Air freight costs follow, which means the prices of anything that moves by air, fresh produce, pharmaceuticals, electronics components, move with them. Shipping costs follow the same pattern on a slightly longer timeline, feeding into the price of manufactured goods, consumer electronics, clothing, and food. Fertilizer prices, which are tightly linked to oil and gas input costs, begin transmitting into agricultural prices within a season. See, energy-intensive industries face immediate margin compression when fuel costs spike unexpectedly, and chemical and petrochemical producers, which use hydrocarbons both as feedstock and fuel, experience particularly severe impacts from oil and gas price volatility. That means the plastics industry, the pharmaceutical industry, and the packaging industry all start repricing at the same time. The result is that a supply disruption in a narrow waterway in the Persian Gulf shows up in your grocery bill, your electricity bill, your mortgage repayment indirectly through inflation, and the cost of replacing the tires on your electric vehicle. The EV owner charging their car in a garage in Munich or Toronto is not insulated from any of this. They are simply insulated from one relatively small part of it, the petrol station, while the rest of the system reprices around them in exactly the same way it reprices around everyone else. So, if electric vehicles are not the shield against oil shocks that they are often marketed as, what is? The honest answer operates at two levels, the personal and the structural, and neither of them is as satisfying as the marketing around EVs, which is probably why you do not hear about them as often. At the structural level, the things that genuinely reduce a country's exposure to an oil shock are energy diversification at the grid level, domestic manufacturing capacity that shortens supply chains and reduces the shipping oil embedded in everything the economy consumes, strategic petroleum reserves large enough to genuinely buffer a prolonged disruption rather than just buy a few weeks of price stability, and serious investment in electrifying the sectors that passenger cars have never touched: aviation, shipping, and industrial petrochemical feedstocks. Those are the floors of the building that are still entirely on fire, and they receive a fraction of the political and media attention that goes to debating whether a particular car model qualifies for a purchase subsidy. At the personal level, the most meaningful things you can do to reduce your exposure to oil price volatility have very little to do with what kind of car you drive. They are about the energy efficiency of your home, the oil intensity of the food you eat. Industrial agriculture is deeply dependent on petroleum-derived fertilizers and diesel-powered machinery. The degree to which your income and savings are exposed to energy cost inflation, and your general resilience to the kind of broad price increases that an oil shock triggers across an entire economy. While driving an electric vehicle is genuinely better than the alternative for many people in many contexts. The emissions reduction is real, the running costs are lower in most markets, and the technology is improving rapidly. None of that is being argued away here. What is being argued is something simpler, that the framing of EVs as a solution to oil dependency is a story that is true in one narrow lane and incomplete everywhere else. The oil shock happening right now, the largest in 50 years, is the clearest possible demonstration of that gap, playing out in real time on every financial market in the world simultaneously. The EV transition matters. It is just not a shield. And the sooner we are honest about the difference between those two things, the better equipped we will be to build the systems that close the gap. If you want to understand how the energy economy works, not the version in the press releases, but the version that shows up in oil prices and grocery bills and geopolitical crises, like this video and subscribe to this channel.